Go ahead, Paula.
Okay, can you see my screen?
Yes.
Okay. Good afternoon. My name is Paula Hirtz, and I also work for the Office of Air Quality Planning and Standards. And I was the project lead for the recent review of the NSPS, or New Source Performance Standards, for auto and light-duty truck surface coating operations. I guess I would like to tell you that I too am a chemical engineer, and I guess I graduated from Penn State. I've been working for EPA OAQPS for about 20 years, and I have worked on various coating regulations along with other 112 rulemakings. This is my first Clean Air Act 111 NSPS that I've worked on, but because I also have experience in the automotive industry. I worked for both General Motors and Ford as a process engineer in coating operations. There you go. Yeah, for this presentation, it provides an overview of the automotive industry, and it summarizes just some of the rulemaking development, the technical aspects, and also the tribal and demographic analysis. I thought I'd go ahead and add that in also, so we can talk about that. This was a presentation for Region 5 for the permitters to walk through the plant, and there are a lot of new employees, so I got together with Region 5 and we provided this training to the new employees before they went out into the plants. It was a little intimidating doing a review of the auto industry because it is very dynamic and it's experiencing a lot of growth. We did identify 45 auto assembly plants subject to the current NSPS and the auto NESHAP. Almost half of the 45 plants are in Region 5 states. Michigan, Ohio, and Indiana had a lot. And, there's a lot of conversion to electric vehicle production. And in 2022, we became aware of the construction permits issued to like the Ford Blue Oval City mega campus in Stanton, Tennessee. VinFast here in Moncure, North Carolina, that's not too far from my house. And then Rivian in Atlanta, Georgia. Also in 2021, Tesla started limited production in Austin, Texas. So lots going on. At proposal, we determined one plant to be a small entity. It was the old Lordstown, General Motors Lordstown plant, which was then Lordstown Motors in Lordstown, Ohio. We determined it was a small entity due to the number of employees, but it was ramping up production. So that was just a temporary situation. Lordstown Motors was sold to Foxconn in May 2022. And since Foxconn is not a small entity, we determined there's currently no small entities in the category. Also, as far as regulatory and emissions, most of the facilities comply with the NESHAP by using reformulated low-HAP coatings and not controls. But most of the facilities comply with the NSPS VOC limits by using control devices. The facilities emit more VOC emissions than HAP emissions from their surface coating operations due to the reformulation of coatings to lower HAP content. And also to, we did delist a few HAPs such as MEK, which they use in their solvents. VOC emissions, according to the NEI, are about 20,000 tons per year. A third of the plants we found had lower VOC emission limits in their permits than the NSPS due to new source review PSD backed or layer determinations. And these were mostly due to new sources that were constructed at existing plants. These facilities emit more VOC than other criteria pollutants we determined. And we determined that the emissions are relatively well controlled. You know, PM from paint overspray is well controlled by the filtration systems. Lead's no longer used as a pigment in coatings. The other criteria pollutants from combustion sources are relatively low compared to other source categories. And the source category was not a significant source of GHG, you know, compared to other source categories. A little bit about the surface coating operations. The coating process starts out with a zinc phosphate system, this is not subject to the NSPS or the NESHAP. It proceeds to 3 primary operations that are covered by the NSPS and the NESHAP, but it does it basically cleans the vehicle to remove particles from the body shop, and it provides corrosion resistance and promotes adhesion between the metal and paint. It's also referred to as a pretreatment or conversion coating. The first operation that's covered by the NSPS and the NESHAP are the prime coating operation. It's an electrodeposition coating process. I don't know how many of you are familiar with automotive coating operations, but it's a tank, and it's a large tank using a waterborne paint. The process is a dip tank, a series of rinses, and a curing oven, and it provides corrosion resistance and surface preparation. Ford refers to it as the E-coat, GM, the ALPO, or it's referred to as cathodic deposition in the industry, and it is an affected source. The two major operations are the guide coat operation, or the primer surfacer, as it's referred to in the industry. This is an affected source, and also the top coat operation. These operations are fully enclosed. They're spray application operations. The guide coat prepares a surface for top coat, and they both consist of downdraft spray booths and ambient flash off zones and a curing oven, traditionally. The downdraft spray booths act as a particulate control system to capture and control paint overspray and solvent emissions. The water containing overspray is routed to the wastewater treatment plant, and organics from the spray booth and oven may be routed to a control device for the guide coat operation. Not always, but usually for the top coat operation. The guide coat may be solvent-borne or waterborne coating, and is applied electrostatically using HVLP spray guns with automation. Basically, the same process goes for the top coat operation, except for in the top coat, it's usually a long spray booth. It has a what is applied as a pigmented base coat for the top coat operation, followed by application of the clear coat. And that can happen in a longer spray booth or 2 separate booths. You know, of course, the top coat has more colors, some solid, some metallic. And that is the high performance coating that's finished for the vehicles. There are other surface coating sources. Paint shop sealers are applied in the shop, in the paint shop. The sealer application is an affected source in the NESHAP. There are solvents that are used throughout the shop. Solvents added to all the paint. to bring them to a specified viscosity. And solvents are used throughout the shop for cleaning and repair. Operations that use solvent are subject to the work practice standards in the NSPS and the NESHAP. And then there is the paint mix area where the paint is stored, and the paint is circulated back to the booth from the paint mix area and back to paint mix. The paint mix area is subject to work practice standards too. Automotive coating technology has come a long way. So you can see here, I think this is a 1959 Chevy Impala. There's no PPE, there's no, it's manual spray. They have their street clothes on. And it does look like a downdraft booth, though. It has the filters above, it's lit, and it does appear to have grates down below. But I did ask Mark if we could take a little time to review this video, and I think that it will work. I'm going to go ahead and give it a try. For about 6 minutes, it will show the body shop. If you've never been in an auto assembly plant, it's pretty fascinating. It shows the body shop and the coating operations. So I'll go ahead and start it, and I'll stop it before it continues. You can watch the rest of it. It goes through trim and chassis if you can watch it later.
The Santa Cruz marks the first HMMA-built vehicle that originated right here in Montgomery, Alabama. This vehicle is not being built anywhere else in the world. My fellow team members, we are the parents of this innovative, stylish, and functional sport utility vehicle. It's truly a limited edition that we can all call our very own.
Vehicles produced by HMMA will be compared to all others. We want to show the world that the best quality and safest cars are produced right here in Montgomery, Alabama, and to be recognized as the best automotive manufacturing plant in North America.
The Santa Cruz is unlike any vehicle on the market today. I have had the pleasure of driving one myself for the last several weeks, and I'm now more excited than ever to present this sports adventure vehicle to our customers. The many options of the open bed combined with the comfort and security of an SUV is going to appeal to drivers in a whole new way.
There's robotics for the major welds now. But they still do a few things manually. They don't have to oil the parts if they stamp them on site. When I worked in the industry, the parts were oiled, and that was always a problem for painting. And of course, now these can be aluminum or sheet metal. Okay, so there's the E-coat process. It's gone through the zinc phosphate process, and And they dip it so that it's, you know, it gets into all the recesses of the vehicle, deep into the interior to prevent rusting. And that's all that you can see. Those the cells on the side. The body is charged negatively, and the cells on the side are positive, and it draws the waterborne paint to the surface. Usually the dip tank is not controlled. It doesn't have any controls. There's a couple of plants we found where the dip tank was controlled, but we found that to be not cost effective for the NSPS. So here's a sealer application. The car body has been primed. It has primer surface or guide coat on it. You can see it's brown, and the E-coat is the gray. Now that sealer will cure in the oven, so there will be emissions from that sealer. And the top coat, this looks like it's spraying like this white color. And those are bare bells instead of those are rotating bare bells, BEHR bells. And so it's a lot more efficient process now. Everything's programmed. That looks like, I'm not sure if that's clear coat. It looks like clear coat on top of the black body, yeah. But everything is wrapped, so it protects the robot. And it doesn't have to be cleaned with solvent. So there are no, there's still manual sprayers. They'll open the doors and spray the inside of the door jambs, but it's robotic now. A lot of robots now, and I think that is a subject when I watch this morning's news. This is inspection and spot repair. And the solvents that are used to wipe down, or any solvents that are used by these folks are have work practices. And I think I'll go ahead and stop it there, but you can watch the rest of it. From here on out, it goes through the rest of the plant, and it has protective covers on the paint. And the doors are put on by robots, so that's pretty fascinating to watch too. Okay, great, that worked. So as you can tell, there's been a lot of surface coating developments. In 1980, the coatings and the coating processes were still under development, and some plants couldn't meet the NSPS limits. The industry converted to base coat, clear coat paint instead of waterborne paints, as we had anticipated when we set those limits. There were innovative technology waivers issued for 9 plants because they could not comply with the NSPS limits for top coat. Today, plants are achieving limits that are much lower than the NSPS levels. Yeah, back in 1980, they were still using a lacquer, and they were using the 2-stage enamel top coats. They used mostly solvent-borne coatings. Only 2 facilities used waterborne coatings at that time. There was no control of the prime coat operation, but the top coat operation was controlled. And they actually did have manual and automated electrostatic spray application back then. Today they have robots. And they are using high solids enamel, waterborne coatings, a lot more waterborne coatings and powder coatings. Most of the top coat operations use waterborne base coat and solvent-borne clear coat. The guide coat operations use both waterborne and solvent-borne. They have tried to combine the guide coat and the top coat processes in a process called a 3-wet process, where they use heated flash off between the guide coat operation and the base coat operation. And then they apply the top coat, and then it goes through an oven for a complete cure. Clean Air Act Section 111 requires a review of the best system of emission reductions, or BESR is the acronym that we use, every 8 years. Of course, we missed that. You know, it was more like 43 years since we took a look at the auto NSPS. We did have, it was a consent decree order. We actually had a consent decree proposal deadline and final deadline. Here, just kind of added, you know, the BESR requirement under 111B1B and the general provisions definitions of reconstruction and modification. So the NSPS Subpart MM had specific applicability to the 3 primary operations in assembly plants. And it applied to facilities that commenced construction, reconstruction, or modification after October 5th, 1979, which was the proposal date. The 3 operations account for 80% of the VOC emissions. And the NSPS was amended in a series of actions. First of all, to provide the innovative technology review waivers, to reduce the reporting frequency from quarterly to semi-annually. And then the industry petitioned us to add a solids turnover ratio to the electrodeposition prime process. And that was mostly to account for periods of non-production. Subpart MM emission limits were based on control scenarios for both solvent-borne and waterborne coatings. Also based on no control of the E-coat and guide coat, and it contained various exemptions. So, you know, if you used waterborne, basically you didn't require that, no controls were required. Waterborne was thought of as a pollution prevention coating or practice. And then alternative 2 was, you know, control of not the guide coat operation, but the top coat operation, both the booth and the oven. The NSPS also exempted plastic coating of all plastic bodies and body parts on separate lines. There was no separate limits for modified sources. The industry would like, you know, for modified sources, less stringent limits. The original NSPS did not have those separate limits. And they had some breaks on model changes. They were not considered to be modifications. And the NSPS required use of default transfer efficiencies that were in the rule. It did require that emission limits must be met at all times, which is good. A lot of the NSPS don't have that condition. No work practice standards were in the rule, and no periodic testing of control devices was required. A few other actions that were more recent that we had to consider were the NESHAP, the CTG, and the auto protocol document. These were all done, 2004, 2008 timeframe, and then we did a risk and technology review on the auto NESHAP in 2020, so pretty recently. Also, we took a look at the PSD backed and layer determinations and took that into account during our review. I had a lot of contact with Region 5 in the state of Michigan to discuss those determinations, and it really helped a lot. Okay, the new Subpart MMA was proposed in May 2022 and had a 60-day comment period. As you can see, the VOC emissions are much lower, and the updated BESR describes how auto plants are achieving the emission limits and how the coating configurations really vary. The prime coat, guide coat, and top coat limits are very low. BESR for the new subpart was based on one control scenario for the prime coat and top coat operations and two equivalent control alternatives for the guide coat operation, depending on the use of waterborne or solvent-borne coatings. Just the complexity of the configurations, they vary widely from plant to plant. So we basically described the prime coat operation at plants that were achieving the 0.23 above. This is what they did. They basically control the oven emissions. For the NSPS for MMA, this is what the BESR is to achieve the 0.23. And then guide coat had a couple of different scenarios, one for waterborne, one for solvent-borne, and top coat is both waterborne and solvent-borne. For MMA, we allowed no exemption for the coating of all plastic vehicle bodies. Really, the only all plastic vehicle body that we were aware of was the fiberglass Corvette in the Bowling Green, Kentucky plant. So they will be, if they modify, build, or reconstruct, they will be subject to MMA. And then we added requirements to harmonize the NSPS with the NESHAP. We added work practices to minimize VOC emissions. We updated the control devices and all the testing and monitoring requirements. We required periodic testing of control devices. We revised the transfer efficiency provisions so that plants have to test the transfer efficiency. They can't refer to just a default transfer efficiency anymore. And that's the same as the NESHAP. We revised the record keeping and reporting requirements. We added electronic reporting. We clarified the startup shutdown malfunction provisions. And we added a whole ton of new test methods and incorporated ASTM methods by reference as alternative test methods. The only thing we did to the existing Subpart MM, we call it the legacy Subpart MM, is that it applies to affected facilities that commence construction, reconstruction, modification after 1979 and before the date of proposal for MMA. We did add electronic reporting provisions to MM so that plants that are currently subject will submit electronic reporting of their semi-annual compliance reports and test results if they do testing. Being in the 112 and 111 programs, that side of the house for Clean Air Act, I really didn't have prior knowledge about NSR. And so I learned a lot about going through these back layer determinations. NSPS, you know, this is the floor for NSPS. The back layer limits for PSD cannot be less stringent than the NSPS limits. And we had that information. We worked with Region 5, and the E code for back layer was the 0.04 there. So in parentheses, the old NSPS value, 1.34, we lowered that to 0.23. So it's more in line with the back layer value. For prime or guide coat, 2.92 was back layer. So we reduced NSPS from 11.7 to 2.92. Top coat was 3.52 for back layer. And that's about what we ended up with for MMA. We also incorporated work practices for purging and cleaning operations. What we did was we didn't cross-reference the work practices in the MACT. We actually went ahead and added them to the NSPS. So it's a standalone rule. Other back layer values there are for, you know, other operations that aren't covered by the NSPS. Our analysis included a demographic and a tribal proximity analysis, and we determined that, you know, because we made the VOC limits more stringent and introduced all these changes, it will have a positive effect on local populations, because we did find that there was a significantly higher national average within 5 kilometers of plants of African American, Hispanic, Latino over 25 without high school education, living below the poverty level. For tribal, we found that there are 6 auto plants are located within 50 miles of tribal lands. So we briefed tribal officials and we offered tribal consultation. But I think because it was beneficial to local populations, they did not request a tribal consultation. So here I just kind of included a table to show the comparison of MM to MMA, the old requirements and the new requirements. It's kind of a reference. And the second table, part of the table, are the NESHAP requirements that we matched in MMA, the new MMA. And I included some of the links to the rules and publications. And that's it. I did want to thank my contractor, ERG, did a lot of great work for me, Brian Palmer. And I wanted to especially thank Dino Blathris. He works at US EPA Region 5 in the permitting section, and Bob Burns with Michigan Department of Environment, Great Lakes, and Energy. I also included some additional background information just because we prepared it for the permitting folks. It just has the Clean Air Act requirements that we had to consider, a summary of the CTG. You know, it's I won't go through it, but it has, if you want to know a little bit more about what's required, and what we had to review, it's there. For these innovative technology waivers, the facilities had closed in 2006. So anyway, this is in kilograms per liter, so it's a little bit different than what I've shown you in the presentation, but so I'm going back through that. Any questions?
Yeah, Paula, we do have one from Sherry Waldron. Is the transfer efficiency a per gun requirement or a type of gun? And was there a lot of work that indicated the transfer efficiencies would vary a lot?
It's per operation. So you might have a variety, and when you look through the rule, I believe the NESHAP is the same way. But for the NSPS, say for the guide code operation, you may have different guns, or the top code operation, you may have different guns that you use. I know for top code, there's, you can have electrostatic HVLP, you can have manual, you can have automatic, you can have even conventional. If you can believe it or not, the industry assured me that there's still an application for conventional, especially so basically it's an averaging of transfer efficiencies that are used on that operation. I was going to say, believe it or not, too, that for the metallics, and I don't know if this is known, but the metallic flake will, if it's applied with electrostatics, it disrupts causes a darkening. So the metallic coating, they have to go back over with conventional non-electrostatic spray before the clear coat, so that it brings it back on color. So that transfer efficiency averaged in, which is low, averaged in with the other transfer efficiencies that are high, it comes out to be, an average. They're all averaged together. Any other questions?
Yeah, this is Mark Stoddard. You had mentioned conversion coatings, the use of zinc phosphate. Are there emissions attributed to that conversion coating process?
I was kind of surprised to see they didn't take a closer look at that, but there's no solvents that are used on that process. It's completely enclosed. From what I understand, when I was in the business, it was all spray applied and completely enclosed. But now, from what I understand, some of it is a dip tank. And I'll tell you what, too, I learned through this rulemaking is it's zirconium oxide is actually the material that they use for aluminum bodies, but it's zinc phosphate for the sheet metal, for the metal that they use. So no solvents and no emissions as far as we know.
So yeah, I was going to ask about zirconium oxide. And you're saying that that's been more widely used for aluminum metal?
For aluminum bodies,
Okay, so one of the big issues with phosphate is the nutrient loading to bodies of water, and so there's an effort to try to reduce that.
Well, we in this effort, we really didn't explore the wastewater treatment and emissions from wastewater treatment. I know that was something the waste that's generated from these operations was reviewed in the 1980 NSPS. That was a concern. Not so much of a concern now. Not to say, I guess maybe we should have taken a look at that. But that would be a wastewater treatment concern.
And I imagine since more water is used, it would be a much more dilute solution going to their on-site wastewater treatment.
Yes. I do know that now with the advent of robotic use, the robots don't simply discharge, purge into the water below the grates in the downdraft booth. They actually go to a cup that is hardlined to a solvent recovery system. And they actually go back and they do a color change and purge, you know, and load the next color. All that process happens, and the waste goes into solvent recovery that is processed by the plant. Because if it's a manual operation, is they will just maybe they do it differently now, but just manual operation was into the water below the grates in the booth. But as you can see in that video, you know, there was no manual operations, but the facility, the association assured us that there are still manual operations for cut-in on the door jambs and etc., where the robots can't get.
Oh, okay. I imagine those are small volumes.
Yeah.
Anyone asking questions other than me and the, you know, oh, here, Tony is ask, how does one get an innovative technology waiver? Are those available for NESHAPs as well?
I'm not sure about 112. I suppose there is some provision. We could go back to it, but the industry actually asked me if that was still available, and it is for under 111. Here it is, 111J and 173. And it did, if you read the Subpart MM, it actually has the 9 plants listed in the rule. It was added, you know, as an amendment, and it has a different limit, and it says that they were permitted temporarily to emit until they could achieve the NSPS limit. And at that time, you know, they eventually did put on controls and they were able to meet the limit. So it was kind of a temporary measure. I believe, you know, the NSPS was promulgated in 1980. 1984 was about the time the waivers were granted, and then I think it was 86. They had just a couple of years to. I think it said 86 or until they could meet the NSPS limit. So it was a little bit open-ended. It was so long ago, though. You know, I was had concern about that at first, but when we took a look at the semi-annual compliance reports for each one of those facilities that were still operating, and found that they were way below NSPS limits now, and that's why we the VOC limits are so low. We saw that they could actually, you know, these plants that couldn't meet these limits at one time now were way below. They were achieving what we proposed, and that kind of helped solidify those low numbers were attainable and achievable by many.
So I think you mentioned something about having to periodically test to verify or validate transfer efficiency.
No, for control device destruction efficiency.
Oh, okay, but not transferring a coating material onto a part.
Right. But the states can still require that. In the rule, yeah, there is not, there's a initial demonstration of transfer efficiency is required, but no repeat.
Okay.
It's that way in the NESHAP also. We follow the NESHAP on that. But there is periodic testing of control devices to make sure that they're meeting the destruction efficiency they demonstrated initially, or most recently, if the state requires them to test after the initial compliance demonstration.
I was kind of wondering if there was data kind of validating and increasing transfer efficiency that could possibly be utilized by perhaps smaller sources that do painting using a variety of application methods. But I imagine that data doesn't exist then.
Well, I don't think the NSPS ever required it. It had a default transfer efficiency that you just used, depending upon if what the application was, what the coding was, and how it was applied. So there was never really any way to know exactly, according to the NSPS, what the actual transfer efficiency was, because they're just using these default values. There was a study in 1980 that, for development of those values, but since then for the NSPS, no. But I think by requiring plants to go ahead and actually measure it, it's a step in the right direction.
Yeah, I mean, anytime you can reduce overspray, that would be a step in the right direction.
Also, there is a requirement, record keeping I believe it is to require sources to go ahead and document the transfer efficiency and the calculations that go into that for EPA to review at their discretion.
Okay. I don't recollect whether the NSPS covers particulate matter, and would that impact the welding that was referenced or made mention in the video?
No, yeah, I know. This NSPS, Subpart M only regulated VOC, and MMA only regulates VOC.
Oh, okay.
But, EPA has talked for 20 years since I've been employed at OAQPS about developing a welding NESHAP, which I still think is an excellent idea because especially working in the automotive industry, walking through a plant to go upstairs to the paint department every day, it is a lot of welding emissions, a lot of PM. Also think about, shipbuilding, aerospace, etc. I still think it's a good idea. I really don't I really don't know why we haven't focused on that, but we usually are in a situation where we are trying to meet our court order deadlines, and with the people that we do have, and it's been, I would say, from my 20 years, I haven't really ever worked on a rule that didn't have a court order deadline, and I do believe that. I don't know if this NSPS actually had a court order deadline back in 1980, but I know that most of the NESHAP did too, back through the 90s. So not to make excuses, but that's really becomes the priority when you have limited resources. But I would encourage you, if you have any concerns about the PM from welding, to continue to suggest that we do that.
Well, like the changes in painting technology, I kind of wonder if there's also changes in welding technology from the use of welding rod to the use of not welding rod, but resistance welding or laser welding, where you would imagine, and I think with welding, manganese, if I'm not mistaken, is the one HAP that could be released or emitted. So I would surmise if you could go to resistance or laser welding or some other or a welding that doesn't require the addition of a rod, you would be decreasing your particulate emissions, particularly manganese, I think.
Mhm. Well, I know, I think the most research we did on welding emissions was at one time shipbuilding and ship repair. Um, and I know there was a lot of submittal of data from those from that welding activity. And Mohammed Sarageldin was worked at OAQPS, and he actually worked on that. I worked with him. Um, so yes, there's data. There's definitely data, not new data, but old data. I would say that was probably from um, maybe 2009 or so.
Okay. I don't see any. Oh, it seems that robot welding is so much more precise and efficient that would have low emissions. That's from Tony Pandola.
Yeah, I think that it is. Oh, did I sign off?
Yeah, I can
Okay.
still hear you.
Okay. Let me. Yeah, I'm not sure about that. We would have to look into it. I would think. I would think that the emissions would be more concentrated. I mean, into one location. If you're doing the major body welds, and maybe they are more concentrated. Come from that particular station instead of throughout the body shop. I'm not really sure about the body shop operations though. Yeah, everything is becoming more efficient at auto assembly plants. I do believe though. Um,
I'm thinking with robotic welding, you could be more precise,
uh,
whereas a human being might be prone to some degree of error.
Absolutely. The main goal of in the body shop is to you have the specifications for the gaps. And I can remember the bodies coming up, and we could not seal the gaps because they were so wide. We put the sealer in the gaps to prevent water leaks, and sometimes if they were off spec, they would be so wide they'd be difficult to seal. So there was a lot of variation. Then I'm sure there's less variation with the robots.
Yeah, I would tend to agree. I don't see any other questions or comments. I do want to thank my guest presenters, Mark Huyu and Paula Hirtz, for their willingness to prepare and give this presentation. I appreciate that. If you know of colleagues that may have some topic or area that you think might be of might be of interest to our small business environmental assistance group, please don't hesitate to suggest maybe names or topics. Maybe talk to your colleagues about who we are and what we do. Sometimes I seem like I have to resell who SBEAP is and what we do, and that we're non-threatening. And the last was kind of a joke. So I thank you, everyone. Our next call will be September 19th, and I'm excited about that. An overview of PFAS in the metal plating and finishing industry by Maya Gilchrist with Minnesota Pollution Control Agency. They they put together, I think, a great presentation dated December 2022. I have kind of been going through it when I've had the opportunity, but I think it presents a wealth of knowledge, and so I'm looking forward to that. Any final parting questions? Anything you want to add, Leanne?
All good here, Mark. Thanks. Thanks to Paula and Mark.
Okay, well, see you later.
Bye.
Bye.